So this is the last part of the Module 4, Cryptography Concepts and VPN. So may tinatawag tayong symmetric encryption. Sa symmetric encryption, it uses this symmetric key algorithm wherein there is a single key, identical ang key, parehas ang susi, okay, or ang shared secret key sa pag-encrypt at pag-decrypt ng data or ng plain text. Okay? Karamihan ng mga gumagamit ng symmetric key algorithm ay ang DES, 3DES, RC, and AES. For certification exam, very important yung pag-classify ng mga different encryption algorithm we have, kung ito ay symmetric or asymmetric or a-hashed. So again, DES, 3DES, RC, and AES are all symmetric key algorithms. Okay. One agenda of symmetric key is for confidentiality. Okay, to ensure that uh, uh, the information being sent is unreadable. Once ang isang attacker obtain a ciphertext, ang main agenda niya is to identify the cryptographic algorithm and the key. So, to make it more complicated, ang ginagawa ay pwede rin mag-apply ng value to the plain text to make it more secured and also to ensure uniqueness. There are three techniques to do this. You may use nonce, salt, or initialization vector. Sa nonce, it stands for number used once. It's usually sequential. There are bits of data ini-input dun sa cryptographic protocol or algorithm um, cryptographic algorithm. Okay? Usually, nakikita ang NAND sa mga message authentication codes and also some other encryption codes. Okay. And then, na-improve yung nonce, nagkaroon ng IV. Ang IV is yung nga, an improvement of the nonce. Nonce siya, parehas ng nonce, yun nga lang hindi na sequential. In random, it ensures randomness doon sa pag-apply ng value. Okay? Yun ang maganda sa IV. Okay? Yun, nasabi ko na, hindi siya sequential, in random. And then, ang salt naman, ay usually ina-apply sa mga password-based system. Okay? Diba, usually, yung mga password-based system ay prone to dictionary attack. Okay? So, mga common words sa dictionary. So, kapag nag-apply ka ng isang value doon sa password, so, malilihis ngayon yung words na yun doon sa mga words na nasa dictionary. Yun ang target ng salt. Kagaya ng IV, ang salt is mga ina-apply na value is it may be random or pseudo-random number or string. We have two types of cipher, stream cipher and block cipher. Sa stream cipher ay yung each bit or byte of data doon sa plain text ay ini-encrypt one at a time, pa isa-isa. Okay? So, yun yung stream cipher. Ang block cipher naman, wherein most strong algorithms uses this, is ang plain text ay dinidivide into an equal size blocks. Okay? Ginugrupo yung mga bits at ang tawag nga doon ay mga blocks. Ang AES, it uses block cipher, yung mga different modes of operation kagaya ng electronic codebook, cipher blockchaining, Galois counter mode, and counter, it uses block cipher. Okay, I have here a YouTube video which gives other details about stream, cipher, and block cipher, in which I do recommend na you take time to watch. So I have a diagram here. Again, sa stream cipher is 1 bit at a time. Okay? Yung pag-encrypt ng data. Sorry, dito pala ako. 1 bit at a time. Ito, nasa baba yung stream cipher. 1 bit at a time yung pag-encrypt ng data, while doon sa block cipher is, like in this case, in this diagram, 64 bits ginugrupo, and then that's when it will be encrypted. So I have here a list of symmetric block cipher algorithms. We start with DES. DES, it stands for Data Encryption Standard. It's an older type of a block cipher. Weak. It has a weak key. Usually, ang weak. The lower the number of bit key, the weaker it is. So ang DES has a 64-bit and saka 56-bit key. So nagkaroon ng 3DES. Ang 3DES is 3 times the DES. I have seen a mathematical procedure of the DES. I will attach that to the blackboard, but we will that is not that is out of scope in our discussion. There are also may ganung material because you know what, mga BS math, they may specialize in this information security. The example, their target is to find out the mathematical technique or approach behind these encryptions. Okay? Yun sila nag-aaral doon. Nang usually ang IT is more on the application side. Okay. So, there, ang 3DES, very important to take note ay uh, 3 times than the 3 times than the DES. Ang mas 3 times than the DES, tama. And then ang mas secured ay before yung AES So as other details from the DES is it supports 64-bit but the key size can be as much as 168-bit. Okay? Sa 3DES. And then ang mas secured na symmetric block cipher encryption is the AES. Okay? It became a US federal government standard in 2002. Ang AES ang successor ng DES and 3DES. AES supports 128-bit block, 192 at saka 256. At again, ito ang mas stronger as compared to 3DES. Meron din tinatawag na blowfish. Okay? 64-bit block size. And then has variable key sizes between 32 to 448. After blowfish, ang sumunod ay is itong twofish. Okay? Which has 128-bit and the key size is up to 256 bits. And then another symmetric block cipher is the RC, Rives cipher. Okay? Ang widely used na stream cipher, RC4 is a stream cipher, naligaw to RC4 is a stream cipher, ginagamit sa SSL, web is for wireless, RDP is yung remote desktop protocol. Okay? At kilala ang RC for its speed and simplicity. I have here details of an AES. So looking at this, I got this from Cisco. Okay? I'd like to focus here. Mga mahalaga dito is yun yung key size niya. So ayun nga, sabi kanina, it supports 128, 192, at saka 256, and again, AES is a symmetric, at saka yung time to crack, ayan. 'Di ba? Proof na it's secured. 149 trillion years bago siya makrack. Okay? And then, ang resource consumption niya is usually low. With the VPN, nakita natin that it is an option under authentication for the phase 1. I have here a table of the summary of the symmetric algorithms. Okay? Mga important details about symmetric algorithms. Mahalaga to sa Security Plus exam. Tinatanong siya usually.
One way of encrypting data is encrypting a block of information at a time. We would take a single piece of information and we would cut it into these single size blocks and then perform encryption on a single block at a time. This encryption that we would perform can be done in many different kinds of ways. We call this a mode of operation, and it defines how that encryption process will occur. Although this encryption process is using the same size blocks during the encryption process, your data may not fall perfectly into that particular block size. If the particular mode of operation that you're using requires a fixed block size, then it's very common to pad the data that you've added to come to the exact size that's required for that encryption mode. One of the simplest modes of operation is called ECB, or Electronic Codebook. This mode of operation is so simple that it's not commonly used for most use cases that require encryption. Each block that we're going to encrypt is going to be encrypted with exactly the same key. With ECB, we start with a block of plain text and we have our key. We put both of those into the block cipher encryption and we receive some ciphertext. We take the next block of information and we perform exactly the same function with exactly the same key. One of the challenges with ECB is that if we do have blocks of plain text that are identical, our key is obviously identical between all of these, and the block cipher encryption process is the same, which means that ciphertext at the end of these three identical plain text blocks will also be identical to each other. If we were to look at this visually, we would see, for example, a picture that I might want to encrypt. And if I encrypt this using ECB, Electronic Codebook, without any other type of randomization for each block, you'll see that it becomes very easy to discern exactly what it was that I originally was trying to encrypt. A popular mode of operation that's relatively easy to implement is CBC, or cipher block chaining. With cipher block chaining, we add some randomization into the block cipher process. We take each plain text block and we XOR it with the previous ciphertext block that we created. This is adding the randomization that we didn't have with our electronic codebook mode of operation. We obviously don't have ciphertext for the first block that we're using, so we'll use an IV, or initialization vector, to be able to add randomization for the very first block that we encrypt. The process for cipher block chaining isn't much more complicated than the electronic codebook, but we add the randomization with the initialization vector that is XORed with the plain text block. That's then added to the block cipher encryption with our key, and we receive the final ciphertext of that block. For the second block that we need to encrypt, instead of using the initialization vector, we'll take the ciphertext that we just encrypted and use that as the XOR to add more randomization. That's then added to the cipher block chaining. We'll add our key and receive the next block of ciphertext, and so on. With these previous modes of operation, there were fixed size blocks. But what if you were streaming information and you never had a block worth of information to be able to encrypt at any particular time? For that type of encryption, we may want to use the CTR mode, or the counter mode of encryption. This is a block cipher mode that acts like a stream cipher. This mode uses a fixed size counter that takes the place of the fixed information, and then we can add any particular size we'd like of the information to be encrypted. Instead of using a 128-bit block, for example, we could encrypt 8 bits at a time. This starts with a counter. Then we can start this counter at 0 or any number that you would like. We would encrypt this using our key in counter mode. We would XOR the result with our plain text block to create the ciphertext. We would perform the same function on the next block, but we're going to increase the counter by 1. We're going to encrypt that using our counter encryption mode with our key, and then we'll take our plain text block and XOR those results to get the final ciphertext. For subsequent blocks, we will continue to increment that counter, and that's also providing the randomization that we need if any of our plain text blocks happen to be identical. If you need to combine authentication with these block mode encryption methods, you can use GCM or Galois counter mode. This combines the counter mode that we just saw with some additional functions that were created by Évariste Galois, the mathematician. One of the advantages of the GCM mode of operation is that we're able to provide both encryption and authentication at the same time. And we're able to do this with a minimum amount of latency and a minimum operational overhead. Because of this efficiency, it's common to see GCM being used for network communication. You'll see this on wireless networks and IPsec encrypted tunnels, and it's commonly used for encryption to a web server using SSH or TLS.